States of Matter in Space by Jerry, Sherry, Elena, and Grace.
All natural matter in the universe can be divided into four states: solids, liquids, gases, and plasma. Plasma is the most abundant state of matter, taking up 99.9% of the known universe. It is superheated matter, and the electrons are ripped from the atoms, similar to a gas, but has free ions and electrons, which give off light. This form of matter is everywhere, from the sun to lightning and storms. Gas is the next most common state, in nebula and planets. Solid is the third most common state in the form of cosmic dust, terrestrial planets, and comets. Liquid is the rarest state, with the only discovered naturally occurring liquid being on Earth.
Knowing information about these states can help us understand space better. For example, if we know that liquid changes into a gas when heated and changes to a solid when cooled, we can figure out that there isn't much liquid in space because most places are either super hot or cold. We can also figure out that stars are made of plasma because it is too hot for the other states of matter. This also contributes to observable properties. For instance, stars shine from the behavior of molecules. Nuclear fusion converts hydrogen atoms into helium atoms, which produces a lot of heat, causing stars to shine.
Something is usually a solid if it can hold its own shape and is hard to compress. The molecules in a solid are closely packed together and have a higher density. In liquids, the molecules have the ability to slide past each other. A liquid will take on the shape of the container it is being held in. Atoms in gases are more spread out than those in solids or liquids, colliding randomly with one another and able to be compacted more easily.
An important phenomenon in space is the formation of stars from nebulae, or a gas turning into a plasma. All stars come from nebulae, or star nurseries, a cloud of dust and ionized gas, comprised mostly of the elements of hydrogen and helium that can be millions of miles to hundreds of light years in diameter. A star is formed when gravity starts to cluster the dust in a nebula together, creating larger and larger masses from their growing gravity. Later, these balls of dust will become so big that they collapse, which will heat up the core and start spinning, beginning the life of a star. Scientists say that other matter inside nebulae can create planets, moons, maybe even entire solar systems, turning a gas into a solid. This phase change of gases to plasmas and solids is an example of states of matter in space.
The many phase changes stars go through are a phenomena that shows states of matter in space. Stars are balls of plasma, and the lifetime of a star depends on its mass. The first stage of a star is the protostar, created by the hydrogen in a nebula heating up. Eventually, the core temperature exceeds 10 million Kelvin, forcing nuclear fusion to occur, making hydrogen in the star convert to helium. The star glows and contracts, making it stable. This is the main sequence stage, like our sun, which will be constant for millions of years. However, the hydrogen supply in the core will ultimately run out and stop producing heat, causing the core to become unstable. The outer shell of the star, which is still mostly hydrogen, expands and cools and glows red, reaching the red giant phase. All stars go through this phase, but the star's mass determines the next steps. Smaller stars, like the sun, cool down and stop glowing, and the outer layers are expelled, forming a planetary nebula. The core collapses and remains as a white dwarf, later cooling to a black dwarf. Massive stars explode as supernova, scattering star material across space, which form into nebula. If the remnants of the explosion are less than 3 times as big as our sun, it becomes a very dense neutron star. If the remnants are larger, the force of gravity will be very strong, and the star becomes a black hole. From gas to plasma to solids, stars are a great example of states of matter in space.
Galaxies are groups of stars, gas, dust, and dark matter held together by gravity. The first galaxies took shape around 1 billion years after the Big Bang, or 12 to 13 billion years ago. The composition of these galaxies have changed over billions of years by interactions with groups of stars and other galaxies. There are 2 leading theories to explain how the first galaxies formed. One says that galaxies were born when vast clouds of gas and dust collapsed under their own gravitational pull, allowing stars to form. The other says the young universe contained many small lumps of matter which clumped together to form galaxies. The Hubble Space Telescope has photographed many such lumps, which may be the precursors to modern galaxies. According to this theory, most of the early large galaxies were spirals, but over time, many spirals merged to form ellipticals. The truth may be that some ideas of both these theories, but either way, the formation of galaxies are of gases, dust, and dark matter, an example of states of matter in space.
There are many different careers regarding space, but a very relevant one is a plasma physicist. To become one, you normally obtain an advanced degree in physics or aerospace engineering. However, there is not a specific degree that you must get, and different roles require different things. Many plasma physicists study ways to create fusion reactors or design a spacecraft for planetary exploration involving plasmas. Also, they can be experimental physicists who might study the effects of plasma on spacecraft thermal protections, or computational ones who develop models of hypersonic plasma flows. This is one career in the vast field of science that interests our group.